Voyager 1, NASA's farthest voyaging rocket, continues its amazing venture through space, flawlessly communicating significant information from the deepest areas of the universe for almost 50 years. This phenomenal space probe has revolutionized our understanding of space. However, as of late, to space apparatus has been communicating disturbing information back to Earth, leaving the entire space industry in SH. Are these troubling signals the result of a technical breakdown or the activities of extraterrestrials? Join us as we uncover the reality behind these stunning transmissions. Since the beginning of recorded history, researchers have been enthralled by the secrets that lie beyond our heavenly boundaries. This interest prompted the historic launch of the Voyager 1 and Voyager 2 shuttles, among other wonderful space missions. These momentous missions, which have been discussed for quite some time, began with the launch of Explorer 2 from NASA's Kennedy Space Center on August 21, 19,774 days later. On September 5 of that same year, Voyager 1 followed suit. These twin probes, each weighing a significant 720 kilograms, comparable to a small vehicle, were propelled into space during a unique alignment of the outer planets. Throughout their staggering odyssey, these courageous voyagers navigated different directions and speeds, leading to a crucial moment on December 15, 1977, when Voyager 1 outpaced its identical twin due to variations in their path. Since then, Voyager 1 has become a significant asset, providing us with a wealth of information and unraveling space-related secrets. Before we delve into Voyager's startling new discovery that stunned the entire space industry, let's explore the exceptional images captured by the rocket during its pivotal Jovian imaging mission in 1978. Voyager 1 was positioned roughly 265 million kilometers from Earth. From this vantage point, it communicated a stunning number of photos back to Earth. In January 1979, it embarked on its exceptional 100-hour endeavor, capturing a mesmerizing time-lapse film exhibiting 10 rotations of Jupiter. A cornucopia of 3,750 pictures allowed us to observe Jupiter's magnificent dance in vivid detail. In the ensuing months, Voyager 1 wandered through the Jovian moon system, making a striking revelation: the presence of a small ring surrounding Jupiter and 2 new moons, which further expanded our understanding of Jupiter's fascinating domain. To ensure safe passage and prevent a potential impact with Titan, one of Saturn's moons, corrective maneuvers were executed. Voyager 1 continued its celestial journey around Saturn, revealing 4 additional moons: Mimas and Celis, Dione and Rio. With the culmination of the Saturn mission, researchers decided to conclude the Voyager planetary mission, pushing both Voyager 1 and Voyager 2 beyond the bounds of our planetary group, leaping through space at an astonishing rate of 325 million km each year. In January 1990, another chapter began: the Voyager Interstellar mission. During this stage, Voyager 1 delivered some of the most famous photos in history, immortalizing the Sun and the majority of the planets. One person who played a vital role in extending the missions beyond their initial OBIs was the prominent astronomer Dr. Vasily SS. As part of the Explorer mission's imaging team, Dr. Sands Entley advocated for capturing one final set of pictures as a goodbye gift to humanity against all odds. His steadfast determination bore fruit on February 14, 1990, when Voyager 1, positioned 6 billion km from the Sun, embarked on a visual excursion well known as the Planetary Group family. Picture these stunning images totaling 60, added to the shuttle's remarkable collection of 670 photos during its encounter with Neptune. Voyager 2 achieved an extraordinary accomplishment by recording wind speeds exceeding 13,100 meters per second, making it the fastest wind ever documented within our local planetary group. Is the rock adventured within 280 million km of Neptune's blue methane atmosphere. It provided us with remarkable insights into this distant celestial body. Notably, Neptune's largest moon, Triton, was revealed as one of the coldest residents within our planetary group, with surface temperatures plunging to a frigid minus 391 to F. Triton's peculiar features, such as its nitrogen gas spewing ice volcanoes that pushed icy particles 5 miles into its nebulous atmosphere, also captivated our imagination. The exceptional discoveries expanded our comprehension of the vast variety and complexity of celestial objects residing in the farthest reaches of our local planetary group. Don't go anywhere. The Voyager 1 rocket has recently made one of its most frightening discoveries, but first let's find out what it has achieved. In the last 45 years, the accomplishments of the Voyager twin tests have been nothing short of extraordinary. More than 4 decades ago, their initial observations of Jupiter and Saturn's moons left scientists in awe and shattered previous assumptions about these remote worlds. These moons, once believed to be dormant and heavily scarred like our own moon, turned out to be teeming with geological activity. Voyager 2 in particular achieved several exceptional feats during its journey. It made history in 1986 by becoming the first shuttle to fly by Uranus. Just 3 years later, achieved another remarkable feat with a flyby of Neptune. Up to the present day, it remains the sole rocket to have ventured on such a path as the Voyager rockets continued their journey. NASA implemented various measures to extend their operational lifespan over recent years. Unnecessary parts and heaters have been deactivated to conserve energy, ensuring that these courageous explorers can continue their mission well into the next decade. Their estimated mission end date is set for 2030 for the scientists and engineers who have been involved in this remarkable project from the very beginning. The culmination of the Voyager missions is both a moment of pride and a tinge of melancholy. Their steadfast dedication and passionate efforts have far surpassed their initial expectations. The wealth of data returned by the Voyagers has provided valuable insights, fueled numerous scientific discoveries, and ignited the imagination of countless researchers and space enthusiasts. Voyager 1 and Voyager 2 were no ordinary space probes. They were meticulously designed as stable platforms with a rotation rate over 15 times slower than the hour hand of a clock. This designed to vision minimized visual blurring as the spacecraft captured images and data while journeying through the infinity of space. Even before their encounters with the outer planets, their impressive imaging abilities began to astonish scientists and the public alike. The spacecraft began transmitting images of Jupiter before reaching the gas giant. These early images, displaying the swirling clouds and iconic Great Red Spot, delighted audiences at NASA's Jet Propulsion Laboratory. However, it was the discovery of active volcanoes on Jupiter's moon Io that truly took the spotlight. Io, somewhat larger than Earth's moon, turned out to be the most volcanically active body in our solar system. The spacecraft's instruments identified peculiar signals from Io, which were confirmed by the distinctive images they captured: towering volcanic plumes and a surface scarred by volcanic eruptions were revealed. One of Io's most prominent volcanoes erupted with a force 10 times greater than Mount St. Helens, covering an area almost the size of France, while the spacecraft's cameras were ultimately shut down to conserve power and memory before their journey into interstellar space, it is noteworthy that the photographs that capture did not include Mercury and Mars for various reasons aside from the Voyager 1 and Voyager 2 interstellar probes. NASA has also operated other prominent spacecraft, like Pioneer 10P11 and New Horizons. Voyager 1 passed by Voyager 10 on February 17, 1919, marking the occasion when Voyager 10 became the most distant spacecraft. Voyager 1 continued its solitary journey for an additional 14 years before finally entering the interstellar environment on August 25, 2012. Although there were no other space probes in sight to witness, NASA didn't publicly announce this remarkable achievement until 2013. What procedures ensured the success of the Explorer missions? One method stood out as particularly brilliant: gravity assist maneuvers. These maneuvers played an essential role in propelling Voyager 1 and Voyager 2 on their audacious mission to explore the outer reaches of our solar system. To reach these distant destinations and gather valuable data, the spacecraft needed more than just their own propulsion systems. They needed a boost, and gravity assist provided just that. Imagine the two fearless rockets, Voyager 1 and Voyager 2, embarking on their grand tour through the local planetary group. Instead of relying solely on their motors, they engaged in a celestial dance with some of our local planet's heavyweights. These planets formed groups that performed in incredible dance, leveraging the vast gravitational pull of these giants to slingshot themselves on their way. This method allowed them to conserve valuable fuel and gain the necessary speed to visit various destinations. Delving into the fundamentals of gravity assist, also known as a gravitational slingshot, we see that the idea behind this maneuver is to transfer some of a planet's energy to the spacecraft as it passes by. Imagine Voyager 1 approaching Jupiter, a massive gas giant with a matching gravitational pull. With meticulous precision, Voyager 1 swung by Jupiter at the perfect angle and speed. Jupiter's gravity tugged at the spacecraft, accelerating it to a higher velocity and providing it with a significant boost. Performing a gravity assist maneuver requires exceptional precision. If Voyager 1 had approached Jupiter at the wrong angle or speed, to slingshot might have resulted in disastrous deviation from its intended course. Though level of accuracy required is daunting, however, the brilliant minds behind these missions successfully executed these gravity assists multiple times, propelling the Voyager spacecraft on an astonishing journey through the local planetary group. Voyager 2, for example, utilized gravity assists from Jupiter and Saturn to reach Uranus and Neptune. These celestial maneuvers were of vital importance in making the grand tour possible. The Voyager missions owe much of their success to these gravity assist maneuvers. Voyager 1 continued to reach interstellar space, with Voyager 2 quickly following suit, all thanks to the accuracy of these maneuvers. The concept behind gravity assist is simple, but the execution is extremely complex. Voyager 2's grand tour required a level of precision where missing any of these slingshots could have resulted in a failed mission. However, the dedicated individuals behind these missions were determined and steadfast in their pursuit of knowledge. While gravity assist played a significant role in exploring the universe, another critical component ensured the success of the Voyager missions: the Deep Space Network, DSN, often considered the interstellar phone line that kept us connected to our brave Voyager probes as they ventured into the great unknown. The DSN, though less flashy than a spacecraft, is equally indispensable. The Deep Space Network is a system of massive radio antennas strategically positioned around the world, including locations in California, Spain and Australia. These gigantic dishes ranging from 26 to an incredible 7 am in D act as vast amplifiers, facilitating communication with spacecraft traveling beyond our planet. The Voyager probes, equipped with cameras, sensors and instruments, served as our eyes and ears in the vastness of space, to make sense of the data they sent and to provide them with new instructions. A robust communication system was essential. That's where the DSN came into play. Imagine Voyager 1 on its way to the outer reaches of the solar system. Sending a message back to Earth is a faint signal traveling at the speed of light as it traverses the infinite expanse. The signal weakens by the time it reaches Earth. It's a faint whisper. However, the colossal radio antenna is of the DSN are poised to capture the whisper. They lock onto Voyager weak signal, working on it and transforming it into data that scientists can analyze. But the DSN doesn't just receive signals. It also sends commands. The Voyager missions are dynamic endeavors requiring scientists and engineers to adjust trajectories, redirect the spacecraft, or tweak instruments. The commands are sent via the DSN, which transmits them into space to reach Voyager and guided it. Operates as a two-way conversation between Earth and the farthest human-made objects in the universe. One remarkable aspect of the DSN is its tireless operation. It works tirelessly 247 listening for those distant signals. It's like an unblinking eye on the universe, ensuring that we stay connected to our space probes even when they are billions of miles away. The Voyager mission stands as a testament to the power of collaboration and innovation. While the spacecraft embarked on their grand journeys, the DSN ensured they were never truly alone. It bridged the gap between our planet and the unknown, enabling us to explore the outer planets and venture into interstellar space. Did Voyager 1 experience a breakdown, or were aliens involved throughout its remarkable 45-year journey in space? The Voyager 1 space probe has remained healthy, diligently performing its mission. However, in recent times, experts have noticed some abnormalities in performance that have sparked interest and curiosity. Voyager 1 is currently sending peculiar signals back to Earth, creating the impression that it is uncertain about its exact location. Coordinates. What makes this discovery even more perplexing is that the initial data received from Voyager 1 were incomprehensible and unimaginable, leaving NASA scientists puzzled. Upon examination, scientist is found that the culprit behind the distorted data was the attitude, articulation, and control system AOX. This embedded equipment is responsible for measuring, reporting, and adjusting the spacecraft's position in space. It has an antenna directed towards Earth, enabling it to send data back home. The malfunction had occurred when the software abruptly changed to sending its telemetry data through a faulty embedded computer that had been dormant for years. NASA engineers were able to correct this anomaly by instructing the spacecraft to resume sending data through the correct computer. Thus, uncorrupted data from Voyager 1 is once again reaching NASA. However, the question that remains unanswered is why the spacecraft switched to the malfunctioning computer in the first place.